So we've looked at implicit differentiation, haven't we? So one of the last things we need to look at is parametric differentiation. Now, parametric differentiation can be quite difficult because we don't know what parametric equations are. So at the moment, we've been dealing with equations like x squared add y squared equals 9. Or, I don't know, y equals 2x squared. We've been dealing with these sorts of equations so far. And these are Cartesian equations. Right, these are from René Descartes in the xy plane. Alright with that. Now, what happens if I bring in another variable, for example, i.e. x equals 3t squared, for example, or say y equals 2t minus 5. These are no longer Cartesian equations. These are in terms of a parameter, so we call them parametric equations. It is fundamental that you know what the difference between Cartesian and parametric equations are and be able to convert between the two. Because you might get a question where it actually wants the gradient function of this set of equations. Now, at the moment, you don't know what to do with that. Because all you've been taught is how to deal with equations that are of the form x squared plus y squared is 9, or y equals 2x squared, for example. So, you've not been able to see fundamentally the things that you need in order to sort of build up essentially what's going on here. So, it's when we've got things of the form, let's get rid of this actually. X equals a function of t, and y is also a function of t, but a different function of t. We'll call that g of t. So we'll stick with what we have. X is 3t squared, y equals 60 minus 5. Okay, so it's like, well, what do I do? It's like, well, I'm stuck. I don't know what to do. Well, dy by dx is part of the chain rule, because these are in chains, these are pieces of each other, right? So it's just take the derivative of the first one and multiply it by the derivative of the other one, or flipped, because we know the chain rule is dy by du times du by dx. Well, I've just got t, what I can bring in. I've just brought t into the case. So, if I was going to differentiate x into 3t squared and y is 60 minus 5, without the knowledge we know so far, well, I'd have to sub that one into there. Now, if you think I'm going to go ahead and substitute one variable into there, then t is 1/6 of y plus 5. I can do it that way. And substitute in. I can show you that way. We'd have x equals 3 lots of 1/6 y plus 5 squared. I have to go ahead and expand that one. I mean, it's not terrible, but I can do it. So that's 3 lots of 1 over 36 y plus 5 squared. So we'd have taken the derivative using implicit differentiation of x. We do to the derivative to the right hand side, which is just 3 over 36, which is 1 over 12, and y plus 5 squared. Go ahead and do it. So, derivative of x, 1, that's easy. Derivative to the right hand side, I have to use the product rule on the chain rule. It was 12 of times by dy by dx, and then times by the power coming down, times by 2 of y plus 5. Power goes down to 1, that's where power 1. So we've got 2 times 12, which will be 6. So it's going to be 1/6 dy by dx of y plus 5 is equal to 1. And then, well, times by the 6, it's 6 dy by dx, 6 dx, what I want, is 6 over y plus 5. What is y? 6t minus 5. So it's 6 over 6t minus 5 plus 5. 6 over 6t, which is 1 over t. Okay, that's not bad. It's pretty slow, but yeah, it gets you there. Let's use this then. So I can find dx by dt, which is just 6t. dy by dt is just 6, just differentiating them normally. Now, I need to find dt by dx, which is 1 over that. So, it's 6 times 1 over 6t. Well, my 6's cancel, and I get left with 1 over t, exactly as I got using this method. But that is a hell of a lot quicker and a hell of a lot smaller amount of working. So, if you're in an exam, seriously, do not go down the method of using implicit differentiation. You think you're going to get loads more marks. You're not. Do it the same amount if you did using the parametric method using the general. But one thing that we must remember is that we must remember the formula. Alright? Because this is not given to us, it is one we have to learn and memorise for our exams, for the pure papers. Okay? So in the next video we're going to go through some more examples of these and put it into a bit of practice with some examples.